So I would like to start with a note of thanks to the organizers of this session who included mental health and physical health in the same session. I think for far too long we've had this dichotomy between physical and mental health, which really doesn't make a lot of sense. And speaking of mental health, mental illness is an important issue. We know from many studies that it's all around us, it's very prevalent. We know that roughly 1 in 4 adults will suffer from a diagnosable mental health condition in any 1 year. We know that mental illness goes undiagnosed and hence untreated for a lot of people, which is also a big problem. And we know that mental health is really impactful. It creates a lot of human suffering, and it has a very serious economic impact as well on society. So it's something that's important, and it shouldn't be treated as a poor relative of physical health care. I come from a company called ISO Digital Health based in Cambridge, England. And we make it our mission to make high-quality therapy available to all who need it. Our service provides mental health care, what would be considered outpatient health care for high-prevalence conditions like depression or anxiety disorders to patients. What's different about our service is that all the therapy happens online via text exchanges. So the patient and the therapist, they talk to each other via text conversations. The vast majority of the therapy we provide is in the form of cognitive behavioral therapy. Because we're working in the UK, we have some constraints about what kinds of therapies we're allowed to use based on the national health system, and CBT is one that has a lot of evidence based behind it, which is why it's one of the therapies that we use. So talking about physical and mental health, it's sometimes useful to take a historic perspective of how we got to where we are today. So if we turn our minds back to the start of the previous century, that's about the time when the first experiments started happening in the area of X-rays. So what you see there is called the Crookes tube. It's one of the first devices to emit X-rays, and people started noticing that these rays pass through bodies and they can be captured at the other end. And that's one way to get a projection, an image of what's happening inside the human body. So that's kind of the level of technology that we had 120 years ago. Somewhat coincidentally, around the same time, psychotherapy started being a thing as well. So the idea of treating patients' conditions by just talking to them was something that was quite new, and it started around the same time. And you know the typical image of the patient lying on a couch and the psychotherapist with a notebook and a pen. So that is, I suppose, technology. That's what they were using 120 years ago for psychotherapy. Fast forward to today, and in physical healthcare, we have something like a computer tomograph, which is the air of the Crookes tube is a lot more complex. It does essentially the same thing. So it exposes the body to X-rays, captures them on the other side, and it produces an image on the inside of the body. But as you'll appreciate, it's far, far, far more complex than the Crookes tube, excuse me. So I'm sure you're all very excited to hear what is the advancement in technology for mental health care. Well, today, we're the proud users of notepads and pencils. That's the progress we've made. Actually, I'm being a bit unfair, to be honest. We have a bit more. We also have PDFs that we can give to the patients to read at home and to better understand their conditions. So clearly, that's not good enough. And one reason for this situation is that a lot of the information that's relevant to the patient's condition in mental health care is locked inside their cognition, inside their language. And up until very recently, the only device capable of understanding human language was another person. So it's only a therapist that could have the conversation with the patient and understand information that is relevant to diagnosing and treating that patient. Fortunately, as we all in this room are aware, there's been great advances in AI, and especially natural language processing, that is now being able to start looking at patient language and therapist language and understanding what happens in therapy, and hopefully allowing us to make progress. So if we're talking about AI, the canonical example of AI is self-driving cars. Everybody who hears I work in AI asks me about self-driving cars. So rather than reject that, I think I'll just lean into it and start talking about self-driving cars. So when we talk about that, we talk about cars that drive themselves, that are autonomous. But there's actually, the Society of Automotive Engineers define multiple levels of self-driving, and that there are two main tiers of these levels. So you have the autonomy features, which is what everybody thinks about when cars drive themselves, some of the time, most of the time, or all of the time. These are the three levels there, essentially. And that's something that started to work in certain conditions, but it's still a dream today. Below that, there's the assistive features that already exist and most modern cars have. Things like even the simple cruise control, but then you have lane assistance, you have safety features that warn you when there's somebody in your blind spot. There are features that automatically brake. So there's another level of features that are not fully autonomous, but they provide some level of autonomy that make driving safer and more enjoyable, I suppose. And I'll argue that below that, there's another level, which is the fundamental understanding of how cars work, the mechanics and the laws of physics. You know that if you turn the steering wheel to the left, the front wheels will turn slightly to the left, which will cause the entire vehicle to turn to the left. We understand that because we study physics and mechanics. So moving that to therapy, I'll talk about some of the work that we've been doing on these three different levels. So first, look at the fundamentals of therapy. How does therapy even work? Can we understand what actually happens in the therapy room, and how does that help patients get better? Then, based on that understanding of fundamentals, we have built some tools to support therapists, provide better quality of care to their patients. So if you want, they're a bit like the assistance features of cars. And in the end, I'll show you some of the work we're currently doing in R&D on automating elements of care. So moving on to fundamentals. The core equation of healthcare is that you start with somebody who is sick, you provide some form of intervention, and you hope that they end up being better or being well at the end of that. And the only way we can make this work and we can improve, we can make progress, is to do science, to have observations, to do measurements, to do experiments, and to iterate and to get better at it. So in terms of mental health, it's useful to understand when the patient presents to you, it's useful to understand the so-called patient variables, their demographics, their medical history, other things that may be relevant to their mental health conditions. It's useful to understand the intensity of their symptoms. There are some difficulties there. A lot of symptom measurements in mental health care are self-reported, which means that they're subject to cognitive biases and measurement errors. But it's the best we can do. There is some research being done in using biomarkers, but that's quite far. Once you've understood the patient, you've hopefully made a diagnosis and a treatment plan. You start doing the treatment, and during the treatment, you can observe what happens. What's unique about IESO, where I work, is that because the therapy that's being delivered in our care is done via a text exchanges on our online system, we're able to uniquely amongst other organizations to observe the conversation between patient and therapist. So we have a data set of some 500,000 sessions of therapy where every word exchange between the patient and the therapist is recorded, and we can do science on it. So that's a very unique resource. And alongside the NLP things, you can also observe the statistical data of how their symptoms change, how often they have their sessions, how long are those sessions, how many times the patient failed to present for the session. So there's all kinds of observations you can make during treatment. And then once the patient is discharged from care, you can also do a final measurement of what was their symptoms on exit. Did they actually reach what's considered full recovery? Was that recovery sustained over a longer period of time, and so on. Because of the session today being about NLP, I'll focus mostly about the work that we've been doing around understanding the language around therapy. So at the start, when the patient presents, what's really useful is to understand the problem that they're bringing to therapy, as one of our therapists put it. And here's one piece of very recent work looking at something that's called cognitive distortions. So these are a set of thinking patterns that are not useful, that tend to correlate a lot with mental health conditions. And there are examples, something like black and white thinking. Everything that you're thinking about, it's either amazing or absolutely terrible. There's no shade of gray. Or externalization of self-worth, where you derive your satisfaction from what others think about you. Or personalization, as I have the example on the slide. Everything's about you. Everything that happens is because you've done something wrong. It's usually wrong. It's not so much focused on positive things that happen. or fortune telling. You envision a future that will be terrible, and you're convinced that that's indeed what will happen. So all of these types of thinking, they're elements of cognition that have been noticed to co-occur a lot of mental health conditions, which is why we thought they're important. And we built a deep learning model to identify when these occur in patient language. There's multiple taxonomies of these cognitive distortions. The first one, I think, was proposed by Aaron Beck, the person who invented CBT back in the 60s. The taxonomy we ended up with is one of 9 cognitive distortions. We've built detectors for those in patient language, and then we've looked at the language that patients use in their first treatment session, so the first time they exchange words with the therapist. And out of those 9 cognitive distortions, we found 8 of them have strong, well, statistically significant associations with one diagnosis or another. So they can be used in principle to inform the diagnosis of the patient. So you see on this graph, there's in light green you have depressed patients who ended up being diagnosed with depression. In the yellowish color you have patients who have been diagnosed with generalized anxiety disorder, and you can see there's this clear difference in the language used. This work is currently under review, and hopefully we'll be able to find the paper on our website later this year if things go well. So moving on from the work done at assessment time, the next piece of work I want to talk about is a similar kind of work to look at the language used in the therapy sessions during treatment. Now, what you're seeing here is a conversation that is fake. It's not an actual therapy session. It's produced by one of us because I'm not allowed to show you the actual transcript of a therapy session. But it's realistic. It's the kind of language you will see in a therapy session. And the system that I'm talking about is the little bit that does these yellow tabs. So that's where the therapist is typing. Every time the therapist says something, the AI system will create a tag for that utterance, we call it. And what that tag is, essentially, it is representing the intent of the therapist. So when we speak, when we say something to another human being, we have a reason for saying that. So kind of philosophically speaking, that's our intent. Intent is also a term used a lot in NLP, which is kind of similar to that. And the way we started this work is that we had several clinical scientists work with practicing clinicians, and we came up with the taxonomy of 25 types of intents, and to make things less abstract. So an intent, for instance, is greeting. At the start of the session, the therapist says, "Hello, John, welcome to the session today." So the intent behind that utterance was to greet the patient. Then things that happen afterwards are things like mood check, where they ask the patient, "How have you been feeling for the last week?" If they were given some work to do from the last session, "How have you been getting on with the work I asked you to do?" So that's homework check. And so on. There's all kinds of intents like this. And we have a system that is able to identify 25 of them in the version that I'm presenting here. Since then, we have expanded that to some 50 categories. So why is this useful? It's useful because it allows us to come up with a representation of what happens in the therapy room that abstracts away from the actual words. So I mentioned we have a data set of some 500,000 sessions. Also, for the patients who are involved in those sessions, we have measurements of symptoms. We know whether they got better as the result of what happened in that particular session. We know if in the end they ended up reaching full recovery or not. We know what our diagnosis were. We know all kinds of things about the patient. So we're able to associate the contents of the therapy session with the clinical outcomes. So put together is an amazing data set for doing data science in mental health care, observing the intervention, and then comparing that with the outcome for the patient. And also important, it allows us to turn a therapy session which contains the patient's most intimate worries and thoughts into a sequence of tags that are completely anonymous. So we can do science, we can allow people to look at that data without compromising the patient's privacy. So that's also something that's important. So I'll stop your enjoyment of watching the movie. These are two pieces of work that are based on that work. So on the right-hand side is a paper published in 2019 in JAMA Psychiatry, which did exactly the work I was hinting at on the previous slide. We looked at that point, I think we had something like 90,000 sessions available to us for research. And we looked at the contents of the therapy and associated that with outcomes for the patient. And then here you see a graph from the paper which shows things that have associations with a positive outcome, or things that have associations with a negative outcome. Now, as usual, it's There's no implication of causation here. We don't have a time element in this study, so it's just correlation, which is why some things require a bit of interpretation. For instance, there's an item called risk check, which is what happens in a therapy session if the patient has some indication of risk to them or others. Then the therapist has to stop the clinical work that they're doing, and they have to do what's called the risk check to confirm that they understood correctly and to put in place a management plan if the patient is indeed at risk. We're not saying that therapists doing that is something that's really bad for the patient. Probably what happens here is that patients with a more severe condition are the ones that are more likely to exhibit symptoms of risk, causing the therapist to do the risk check. So it's just association, it's not causation. Although some things are probably causative. One tag that we have is other, which means language that does not seem to have clinical content. So it's kind of just the social glue that allows the conversation to happen. And obviously you need that for creating the relationship between patient and therapist. But if you spend too much time doing other, then there's not that much time left for actual active therapy, so that, and that's detrimental to the patient. So probably that is a causative link. Again, we haven't proven that statistically, but it seems to make sense. And then on the other side of the slide is a more recent work published last year, where we did something similar, but this time looking at patient language. And in this case, we have a smaller taxonomy of tags. We only have those 5 tags you see there, which are inspired from motivational interview. And the most important ones are change talk, which is where the patient is accepting what the therapist is proposing. So, oh yes, I will try that. Oh, that makes a lot of sense. I'll see how that goes. Or counter change talk, where the patient is resisting what's being proposed. That would never work for me. That doesn't make any sense at all. Oh, I could never do that. And we find very strong correlations. So here we're looking at reliable improvement, which is the symptoms of the patient have reduced during treatment, and they have reduced with a statistically significant margin. That's the reliable part of it. So we see change talk is very strong correlation with good outcomes, counter change talk, very strong correlation with poorer outcomes. So getting the patient to actually accept what's happening in therapy is really important. So having shown you some of the work we've done to understand the fundamentals of therapy, what actually happens in the therapy room, which bits have good outcomes, well, associated good outcomes for patients and which not, let's look at some of the tools we've built to assist the delivery of care. So what you see here is what we call the case progress monitor. And on this is one slide in my talk that doesn't have a lot of NLP in it. And what this is about is tracking the intensity of the symptoms of the patient. So the way it works in our service is that at every therapy session, the patient is given a set of questionnaires to measure their symptoms. And the 2 ones that are always given are a questionnaire called GAD-7, which measures the intensity of anxiety symptoms, and a questionnaire called PHQ-9, which measures depression symptoms. And the graphs you see here, let's focus on the top one. Every vertical is 1 session, so this patient has received 8 sessions. At every session, the solid line shows the intensity of their symptoms. The way these symptoms measurements work is lower is better. So what you want to see as a patient is being treated is that those symptoms decrease. Each instrument, so PHQ-9 and GAD-7, they define a caseness threshold, which means that above that value, the patient is diagnosable with that condition. Below that value, the patient is not. So ideally, you want to see a patient starting above the caseness threshold, going down, following below the caseness threshold. So in the top case, that's exactly what happens as the treatment progresses, both on PHQ-9 and on GAD-7, the symptoms, they don't monotonically decrease, but there is a clear trend towards lower values. The patient goes below the caseness threshold in both of those, and they end up recovering. Now, comparing that with the case on the lower side, you can see that that's not doing so well. So the symptoms keep moving up and down, but they're not making any clear progress. And the patient, importantly, ends up above this green shaded area. So the green shaded area is a statistical model based on something called the growth curve, which, starting with the initial symptom severity of the patient with presentation, calculates an area, a range of scores that we have seen before. So if the patient goes outside of that range, that case is what can be termed a statistical outlier, so it requires some attention. And that's how this is used. Our clinical supervision team will look at this and focus their attention on the cases that seem to be requiring help. And to provide further help to these supervisors, what we're doing is that we use some natural language processing based on the papers that I was talking about earlier. We've built a system that automatically analyzes a therapy session and grades it on 6 different criteria based on whether what happened in that session is likely to be something that associates with positive outcomes for the patient. It's a complicated way of saying, did the therapist actually follow protocol? Did they actually do CBT in that session? So in these tables here, each row is a treatment session. Of course, they're numbered differently, but it's the same case that we've looked at before. And if a particular session, so for instance, session 0 on this particular element, if enough time was dedicated to that, they get a green background. If there wasn't enough time dedicated, they get a red background, and somewhere in the middle it stays white. So looking back at the case that was doing well on the previous slide, you'll see it's mostly green. So it's all fine. The therapist is doing what the protocol says they should be doing, and the patient is recovering. For the case that wasn't doing so well on the previous slide, if we look at the analysis here, this dashboard, we see a lot of red. So what happens with this is that our clinical supervisors who have a responsibility for overseeing the care that we deliver, they identify cases that are not doing so well using this mechanism. Then they use this to get a hint of what may be the issue. And then they go and get in touch with the therapist who is treating that patient and give them hints of how to change the protocol they're delivering and how to hopefully bring the patient back on track. So these are 2 examples of assistive features that we're using to support delivery of care by therapists. And my last comments will be in the area of autonomy features, so automating delivery of care. But before we talk about building tools to automatically care for patients, isn't that crazy? Can computers even do that? So if you've worked in natural language processing, you recognize this kind of diagram as something that's used when you do named entity recognition. So you take a piece of text from the domain that you want to work with, and you highlight in different colors the different types of entities or mentions in the text that you care about. So looking at this, it looks like it can be done. So we can represent the entities that may occur in a piece of text from psychotherapy. But there's a plot twist. This is not coming from people doing natural language processing. This is coming from a manual for therapists. So that is a screenshot from a manual that is used in the NHS system in England to train clinicians to treat patients. So not only are we not talking about getting computers to do what humans do, actually what happens here is that we're training humans to do what computers normally do, which gives us a hint that the idea of using computers to provide care to patients may not be such a crazy idea. So I'll speak a bit before I start the video. There's a video on this one, but I know once I started, I lose your attention. There's a big problem that all healthcare systems in the world have in that we don't have enough therapists. And that happens even in the best run and the best funded health systems in the world. So in NHS England, we have a program called IAPT, which stands for Improving Access to Psychological Therapies. It was started in 2008, and there's lots of agreement that it's one of the best programs in the world. And despite that, the access target is 25%. What this means is that the ambition of improving access to, we're trying to get to the point where 1 in 4 people who have a need actually get help. So that's the level. And the main limiting factor there is the availability of therapists. We do not have enough therapists to provide all the care that is required. So what we've started looking at is, can we build some tools to act as an add-on to therapist-delivered care? And for your enjoyment, I'll start the video now. So what you see in the middle is a demonstrator of this tool that's currently under trial. So this is a human being, in this case myself, again, I can't show you patient data, conversing with a conversational agent. So the thing with this little icon is the agent, the other bit is the patient. And there's lots of studies in CBT that show that the time that patients dedicate between sessions to doing their exercise and doing their work that the therapist asks them to do correlates very strongly with the good outcomes. So if the patient spends the time doing the work, they're more likely to get better, and they're more likely to get better faster. So the intent behind this work is to increase the dose of therapy. So build some tools so that the patient can get some therapy in between sessions of therapy. So kind of add on to what the therapists are doing and hopefully get patients better faster. on average, that may require fewer hours of therapy from a therapist for each patient, which means that the limited workforce that we have will be able to care for more patients. That's the big picture of what we're trying to achieve. What's different about us, so this kind of work has been done in the past, not necessarily conversationally, but a lot of digital approaches to therapy, and CBT in particular, started from the CBT textbook, and then they digitized that. So they looked at what's supposed to happen in a CBT session and created a digital version of that. Our approach is to start from what actually happens in the session, not the book, but the actual experience, the actual practice of therapists as they deliver care. And that's what we're using to create this experience. And what you're seeing here is an element called the vicious cycle, where the patient is talking to the digital therapist to understand their condition relating to generalized anxiety disorder, when they have worries, what kinds of other things associated with those worries. There's the vicious cycle is the fact that your worries cause emotions, physical sensations, and behaviors, and these reinforce each other in a vicious cycle, which is why it's difficult to break out of that pattern. So what the agent, the digital agent is doing here is helping the patient understand these concepts, and very importantly, put these concepts into their own words, so help the patient understand them in the context of their own experience, not just giving them some examples from a book, but actually asking the patient to talk about what they have themselves experienced. And kind of some elements of why we think this is likely to be engaging is that it's trying to do things like rephrasing what the patient has shared, so kind of putting the same thing in different words to prove that it understood what the patient has shared. It's not just kind of copying the words of the patient. And then also it's giving a bit of context, it's giving a bit of normalization. So every time the patient shares something that may be difficult for them, the system also kind of puts it into context, saying lots of people with generalized anxiety feel like this is something that happens to, it's normal to feel like that, and kind of implies a hope that with treatment things will get better. Okay, so that was the video this time, and that was also my last slide. Thank you very much.
Thank you very much for this very interesting talk. So we are ready for questions.
Will the patient be aware that he's talking with a bot, or?
In this case, absolutely. So the patient will always be made aware they're talking to a bot, otherwise it would be unethical. So this is not what we're trying to do. We're trying to build treatments, not scientific experiments. So the patient has to be told that they're talking to an agent. And the aim, so this is kind of an R&D project. We have a clinical trial running. We don't yet have the outcomes of it, so I can't tell you if it's worked or not. The aim is that if this works, it will be integrated into the care. So the therapist will mention the bot. It will be something that is part of care. So the patient will be told how to work with the bot. The therapist will be able to look at the transcripts of the activity of the patient with the bot and use that in the next therapy session. So it will be kind of an assistant. We call it a CBT companion. So it's something that helps the therapist care for the patient. I think there's a follow-on. No. Are we allowed follow-ons? Yeah.
Follow-up?
Yeah.
There's an American application which is called Bloom. Bloom, that does psychotherapy, but it's sort of inverted, so that they are sort of giving examples of behaviors, and they're asking to write, but I don't think they're actually exploiting what the people write in there, and I think it would be a good fit to actually implement this methodology there.
Yeah, there are a few groups who are working in this field. There's actually quite a long-running tradition called CCBT, computerized CBT, of tools that do this kind of work. The vast majority of them are, the technology at least, is coming out of e-learning. So it is what I was saying earlier, is digitizing the manual, which makes it a bit unengaging. There's an interesting study that was run by 2 NHS trusts, 2012, I think, called REACT, with two A's, if I remember correctly. Anyway, they looked at two of these CCBT approaches that they were given to patients in real life, not in a clinical trial context, but in actual clinical context. And the statistical mode, so the number of sessions that most patients accessed was 1 for both of those tools. So one of them was a program of 8 sessions, one of them was a program of 12, but a very large number of patients open them once, they don't like them, and they never come back. So that's what we're trying to achieve here. We're trying to make it more engaging by having an experience that's very similar to talking to your therapist, which we know works and it's engaging, we're trying to carry on that level of engagement into a digital solution. We'll see if we're successful.
Thanks. It was a very interesting talk. So one question is, you showed this feedback system to the therapists. Are you doing the same thing, actually giving directly feedbacks and scores to the patients? Because you said a lot is happening between the therapy sessions, and actually at some point the therapy will be at the end, but especially with depression, there are always big problem with fallbacks. So that people have a tool in hand, which is some sort of standalone supporting them.
So direct feedback to patients during care, there are some difficulties there in the fact that you may encourage the patient to change their, so because all the symptom measurements are self-reported, we don't want to encourage the patient to kind of believe that they're getting better and like kind of change their answer slightly to gain the scores, so to speak. So we don't give necessarily feedback during treatment, but what you're talking about post-treatment is something that's really interesting to us. And if you look at the tools like these conversational agents, that could be something that once a patient has actually been brought to recovery, you make available to them to help maintain their gains. So kind of allow them to still have access to some form of care even though they're no longer under treatment. It's something that's definitely possible, but in future years for us at least.
Thank you. I have two questions. One question is, so when you're talking intent, so every intent usually it's like should have like at least like several sentences or several cases, like more or less rephrase. And how do you collect this kind of intent? So because it should be different that the patient should have feelings that he's not talking with something like real automatical stuff. So you need to have like, you need to rephrase somehow or have different way to explain the same intent. And the second question, what is the technical background behind of this? So do you use any cloud technology, I don't know, from Microsoft or AWS or Google Cloud, because they have this kind of intent approach for the chatbots?
Yeah.
So, yeah.
So, in order, intent, the concept of intent comes from NLP, from dialogue systems, where one of the users in the dialogue has an intent and they want to share something. For the work we're doing with patients, we also have the concept of slots. So kind of to give a very simple example, if you use an assistant like Siri or Alexa, whatever, and you ask what is the weather in Los Angeles, you have an intent there, which is you're asking about the weather, and you have a slot, which is the location, in that case, Los Angeles. In our case, we have similar kinds of things. When we ask the patient to share the emotions that they faced in a certain situation, they will say that they are feeling afraid. And then the intent is sharing the emotion, and the slot is fear in this case. So that's how we go beyond just the intents, because you're right, that would be too simplistic a representation. Second question, what technology we use? We don't use off-the-shelf systems. Well, actually, we use some tools from Azure. They have an intent classification system called LUIS, which some parts of our conversational agents use. The other work, the more complex analysis that I was presenting at the start, that's built in-house. We use in that particular case, it's what we call a hierarchical by LSTM system. So you have a sequence-to-sequence LSTM that looks at the utterance of the therapist, and then you have another sequence-to-sequence mode, another LSTM that looks at the structure of the session. So it puts the embedding of the sentence in the context of the sentences that came before, and that trick gives us access to context, and they give us 10% extra accuracy. So we use a combination. We do tend to use embeddings. We do tend to use sentence embeddings, so the BERT-like things, but we've not really used ready-built models because we have large amounts of data, and it allows us to fine-tune existing models through the actual psychotherapy language and make them more accurate for our needs.
We have time for one more question, so maybe the person that is waiting most, I hope, to catch the right person. The others will need to be clarified in the coffee break.
Thank you very much for the last question. You have shown when the therapist is not following protocol, And now I can imagine sort of at least two reasons. Either the therapist might not know protocol, or it's a difficult patient, so he cannot follow protocol. Did you see both cases, or is it mostly one of the two?
Right, so there's a concept called therapist drift. I was talking to some therapists when we started working on the systems, and they're saying that once they finish their training, where they're presenting with therapy and how to do it, they never see therapy language again unless their own. So they see what they do in therapy session, but they have no access to how other of their colleagues do therapy. And because of that, after years since you finish their training, it's quite easy to kind of develop, they call them their own idiosyncratic style, where they actually kind of merge multiple types of protocols and they do something that's typical to them. Many therapists believe that that works really well, but when you do the measurements, it shows that it doesn't. So therapist drift is an issue, and that's kind of the main thinking behind the system. In terms of whether that happens because cases are more complex, it does happen. So there are situations where therapists are not, they have indeed diverged from protocol, but there's a very good reason for that because they're trying to address certain symptoms that are not directed once they're being treated, which is why this system is not a closed loop. So the feedback is never given back to the therapist, it's given to the clinical supervisor, who then can go and have a look at the sessions and use the hints from our systems to drive their conversation with the therapist. We were talking to a group of ethicists when we were doing this work, and they introduced me to the concept of heteromation, where you have automation and you have human elements that become just a cog in the machine. And it's something that you want to avoid. You don't want the human to feel like the computer tells them what to do. So that's why we kept the clinical supervisor in the loop who can couch the messages in the right way so that they have the desired impact on the therapist.
Thanks again to the speaker.
Thank you.